how many of you know what is the data? Data collection. So here we have a question about need for a data science and traffic congestion. So what is a data? According to the science, data is a raw clips, information, collections of numbers, etc. and stuff which are collected and analyzed together to for a particular process or information. So traffic congestion like what are the mostly used apps for traveling? So as you have been 18 and above, everybody has a license, everybody travels for new places. ஒரு புது place போகும்போது how do you find routes? Google map. So other than that, okay. So Gmap, how does Google Map know there is a traffic ahead? How does the Google Map know there is a traffic ahead?
Based on the
previous travels, GPS, such stuff. So that is what data science comes into. There are two types. One is quantitative and qualitative. Qualitative means, for example, consider a group of class. Quantitative the names of persons present here, like names represent and about qualitative since age, numerical data like rows and columns. So here the problem statement which need to be discussed here is you move to a new place, and in the new place, for example, you are traveling for a place called Goa. Okay, you are driving to a place called Goa. You start from Bangalore, and move to the next stop is you go to Bangalore, and then Bangalore is a straight road to Goa is very easy there. So it is very long, but it is the easiest way to go where the Google Map goes. So how does a Google Map know, and how does it create the easiest way to the customers, and the data so this is the case study. So problem statement, so consider yourself as an office mate or a school going student or in college. So how many of you travel by bike to college? Most of you travel by bike or regular. So traffic is you see traffic regularly. So what if a new person comes to the town? You know shortcuts to college now. Shortcuts to what if a new person comes? It is difficult to learn that. So this is where a small data science is implemented in the three maps, and which is the problem is solved. So the next will be explained.
The next topic is data collection. Data collection is nothing but the collection of data. We used to, for traffic condition, we usually the sources of data collection are GPS, then CCTV cameras, IoT sensors, and historical data collections. The location is used to capture the number of vehicles at a particular place or the pattern of travel for reducing the traffic condition. Next, we use CCTV cameras from the highways or things to see the number of vehicles traveling and the average speed of every vehicle. Next is IoT sensors. IoT sensors are used to count the traffic density. And the final one is history of previous traffic. During the weekends, and there is the traffic condition difference between the weekdays and weekends. So and even during seasonal times and occasional times it differs. So the history of traffic congestion is taken, and then it is used for data.
So the methodology of the case study is there are 4 important steps in this. First step, we are going to do data pre-processing. For data pre-processing, we are going to collect the raw data from the CCTV footages, etc. to get the hotspots region and the traffic congestion in our nearby areas or in our town. So after that, we are going to take some clustering algorithms like K-means algorithm for the cleaning of the data for the better processing or the better decisions of the data science. The next one is the data analysis. The data analysis process, as I said before, we're going to use the data clustering algorithms like K-means, etc. And after that, we're going to develop a model. So for the development of a model, we're going to use two important technologies known as OpenCV and ALIMA LSTM. These three technologies are used for the model development of the data for this data sets case study. And after that, we're going to do some real-time implementation of the project. For the real-time implementation of the project, we're going to integrate our case study or the data into the real-time applications like Google Maps, Apple Maps, etc. So by considering it, methodology plays an important role in getting the hotspots region of the area or the town to get the traffic condition slowed.
So the tools and technologies for using for this case study is Azure Data Lake for data storage and processing, and the real-time streaming like Spark Streaming, and the machine learning frameworks like the PyChart or TensorFlow, and the visualization tools such as Power BI and Tableau, etc. So the results and outcomes are achieved. 25% reduction in congestion during the peak hours of traffic signal time, and improved emergency response by 50% using this real-time accident detection, and enhanced computer experience with live traffic and route updates and returns, reduced the fuel consumption and emissions by promoting the smoother traffic flow.
So the difficulty in implementing these projects include we need to collect various data from multiple sources to implement this model, and sometimes we cannot predict the traffic during the weather. We cannot predict the weather and the event times. So that time we cannot predict the traffic. And the conclusion was by using this data science we can reduce the traffic.
Next is the future scope. There are a lot of future scope for this project, but I will just highlight the main 3 points. One is to find the maintenance of roads. These cameras that during the use, we can find the wear and tear of the road so that the road can be maintained properly, which can lead to good safety. Next is drone-based aerial view. If we use drones for traffic congestion, we can have a better view than the cameras that is placed in the roadsides. Next, the main is to have to reduce the delays of emergency vehicles. If in case there is a emergency vehicle in the traffic, the IoT sensor can find it and then it can even change the signal so that the emergency vehicles can move and it can lead to a safety net. Thank you. I hope everyone would have understood this case. Thank you.